important, Indian innovation we should promote करके.
So definitely it has come out from DST, Ministry of Science and Technology funding projects. So I really hope it's purely indigenous.
आपका ये presentation कुछ होगा? PPT करेंगे आप?
Yes, sir. It is there.
Fine. Okay, fine. So you will be doing that PPT, or you have been tied up with the water tech people? PPT show. Okay, fine.
Yeah, we have had rehearsal.
Okay, fine. Thank you. And I'll join in about 15 minutes. Thank you.
Yes, sir.
All right, sir. Hi. Actually, I was not expecting that we are already here. I thought I'll just join, and by 3 we'll start. So that's why I was in middle of, collecting my notes and just putting everything right.
Please go ahead. I was just checking in. I'm all set. Whenever you will say.
Yeah. All right. All right. So just allow us like 5 minutes or so, and I'll be back again here.
Yeah.
All right. All right. Thank you. How are things, Nupurji? Mute. You're on mute.
Fine.
Okay.
So
So you're in which office right now? In this Gurgaon one or in the IHC one?
yeah, it's one. And
Okay.
I told you, I don't know. Now I'm in the water resources division,
Yeah, you messaged.
and a dedicated center, a new area has come up on TEDx Technology Center for Water Reuse.
Wow, wonderful. Congratulations.
Thank you. So now more responsibility, and we have to take it ahead from here.
I'm sure. And anyways, you've been, creating this and then talking about it. And now the time when you'll be implementing also, if I'm right, in one of the projects with NMCG, I guess.
We have submitted. We have
On
yet
the
to
pilot basis, I think. Yeah.
Yeah.
I
First
think that.
pilot
Hmm.
augmentation. So let us see. We have to yet receive the sanction.
I'm
So I
sure
hope
it
all
will.
attendees are connected, or
No, not yet. Not yet. As of now, it is on practice mode.
fine. So I'm glad that we could be connected through this talk. Planning for a long time. So अब अनुप कुमार जी के उस शायद उसमें आ जाए level of inviting.
Come on, don't say that. You'll embarrass me if you say so. Don't say that. Just, not that we never tried. We'd always tried that let's do something together. But somehow, वो कुछ ना कुछ ऐसा रहा that we couldn't.
Time factor is very, very important.
Yeah.
So, that's good.
Yeah. In fact, one of our campaign is also recently on with National Mission of Clean Ganga also for that Ganga Quest. So we have partnered for that.
I know.
Yeah.
I circulated to a large number of schools. I did that maybe.
Okay. So we are officially on board with them.
Yes.
Yeah. So that is also one thing which is on. And then of course, National Water Mission is we really look up to, because
No, we can probably because
yes, are you there,
joining through the Facebook link. So we
yes,
can
sir.
go ahead. We'll give some time for some that video now, so that she can.
Sure,
start
sir,
with,
sure,
okay.
sir. I was just thinking that you are not there because I couldn't.
No, I'm here only. We'll start off.
Okay. So just allow me a second to check if we will be live on Facebook.
The movie be चलेंगे, तब तक the other people can also join.
All right, sir. Let me just check.
Ma'am, we are live.
All right. So a very good afternoon to all of you, and warm welcome to this Tech Talk, an initiative by National Water Mission and is supported by Water Digest. I'm glad to share that we all had been talking about achieving Sustainable Development Goal. We've been talking about various goals for the 2030 agenda, and wastewater management is also reuse and wastewater management is also one of the key goals of this agenda. And today's talk is on a very interesting topic, which is TERI, Advanced Oxidation Technology, as it is being called TEDx, to treat wastewater and enhance water reuse. We have with us Shri G. Ashok Kumar, Additional Secretary and Mission Director, National Water Mission, who incepted the idea of this Tech Talk. After the success of Water Talk, there was a thought process, and sir suggested that let's do some Tech Talk which will be specifically focused for the technical community, the technical fraternity of water sector who is wanting to know and learn more about the technologies. We also have with us the wonderful speaker, Dr. Nupur Bahadur, who will be sharing her vision about this technology. But without further ado, I, Anupma Madhu, the director and editor of Water Digest, would request Mr. G. Ashok Kumar ji for his welcome address. Over to you, Ashok.
Welcome to all of you. This is the first Water Tech Talk after the Prime Minister has launched probably one of the biggest campaigns in the world, the Jal Shakti Abhiyan Catch the Rain campaign on the World Water Day. That's the second. That's the 22nd March 2001. So a brief one or two lines on the Water Tech Talk. After the phenomenal success we had, the water talks started with physical talks, and then 2020 when the COVID attack, we partnered with Water Digest to launch the e-water talk, which really enhanced our reach and in terms of geographical spread as well as in terms of numerical numbers of participants. We thought that we should also get a very niche sector where we will focus on hardcore technology and preferably Indian technology, where we will be able to focus grown cutting edge technology to the people. So it's basically the Water Tech Talk is giving a platform for young entrepreneurs like our Nupur ma'am. I have done a lot of work, very, very pioneering work in this sector, which we talk about. A platform for showcasing their products and also let the people of the country know that this is the type of technology or capability of our people here. We had, I always tend to look forward to the Western countries for any new technology, but the present COVID situation also, we know our vaccine, Covaxin, which is developed in India, is also considered one of the best, and it has much less side effects than the COVID shield, which we are not facing. So we have now Tech Talk also presented many new innovative people from the Indian institutions. We had Dr. Idris Shekhar Sen on the February Water Talk, where he talked about new paradigms for the water quality monitoring. We had on the third Water Talk Dr. T. Pradeep from Institute of Madras, Chennai, on harvesting humidity for clean water, like that. So today we have Dr. Bahadur on her patented technology for the wastewater treatment. Before that, let me take 2-3 minutes on Catch the Rain campaign, which Honorable Prime Minister had launched on 22nd March, as I said. Probably this is one of the biggest campaign launch on water ever in the world, because we had online almost, we had invited 2.5 lakh sarpanchs and DMs, all DMs of the country, barring the election states. Probably at least 1 lakh sarpanchs on board, and each sarpanchs were told to take up the Gram Sabha special and listen to the PM's address. So probably if at least 100 people attending the Gram Sabhas, more than 1.5 crore people watching the program live for the PM. And then also we had asked the Gram Sabhas convene and discuss on water related topics. So entire country, Gram Sabhas, Gram Panchayats on that water day, 22nd March, discussed about water and water related issues, and also Gram Jal Shapath, conserve water. So this is a number which is humongous. We had partnered with Nehru Yuva Kendra, where yesterday's figure, they say that more than 2.404 people have been involved in the campaign of the Catch the Rain campaign across the country, and doing various activities like quiz competitions, slogan writings, wall painting writings. This has really moved into the field. This has become a Jan Andolan, and the next 2 months, that is the pre-monsoon periods, we are focusing on making these natural containers and also preparing the action plan. This is another very important aspect of the Catch the Rain campaign, Jal Shakti Abhiyan. We are telling that the entire inventorization of the water bodies in the country, all water bodies have to be marked and recorded and cross-checked, and encroachments removed and geotagged and kept ready, so that we can do the planning based on that. So we are actually taking the next phase using high technological inputs like NRSA, satellite imagery, as well as geotagging technology to mark the water bodies. And based on the soil strata and based on the water availability, rainwater, and the other water availability, we will probably scientific planning of the water bodies to be taken up. So probably in the next year, we will have a very robust scientific based plans for taking up the water conservation works. This I stop it here. I'll take another 7 minutes for a video on the National Water Mission, and then I will introduce the speaker of the day. So let me take some time for making you a bit of understand the works done by the National Water Mission. Okay, that was video on the National Water Mission. And coming to today's topic, we always had been promoting the 3 R's of water conservation, that is reduce, reuse, and recycle. And in the last 1 year, the National Water Mission had been promoting the other 2 R's also. That's making it 5 R's: recover, regenerate, and respect for water. Now, in this, we have. Echo is coming. Is it? Why is it echo coming? Is it coming echo coming? Why is it coming now? Hello, can you hear me now? I think there was some gap in between.
Yes, sir, we can
hear you.
Okay. Treatment of the wastewater, with the use of treated wastewater is one thing which is really getting the attention of the people and the policymakers, because this is one great source of water for non-potable uses. And we had been using. I think there is some.
So you are audible. You are audible, please.
I am hearing that once again. See, putting. I think you have put the Facebook. Is this? Hello. Okay, fine. Sorry. So I was getting echo from some other channel anyway. Okay. So this use of potable water for non-potable purpose has to be reduced to the minimum extent, so that we have sufficient water conserved for potable purposes. So nothing better than using the sewage water treated and the effluents of factories treated, resources recovered from them, and that water can be used for non-potable purposes. We had been using very important technologies, but our scientists, particularly from the TERI, under the leadership of Dr. Nupur Bahadur, they have come out with a very interesting technology called TERI Advanced Oxidation Technology, or TADOX in short. This is a very interesting technology which is has very great advantages. So this is technologically, if you look at it, they use bare minimum chemicals, they use novel materials for primary treatment, they use properties of nano materials to purify the water. It generates negligible sludge. Very important, because in most of the plants which we found that we were using, we had a problem of sludge. We do not know what is to be done with the disposal of the sludge, and we have still not evolved as to take advantage of the sludge to be used for fertilizers and other purposes. So the sludge is a major problem in many of the STPs. So this technology, they say, is reduces this sludge very much, and the treated water coming out of this technology will have processed water quality, which can be used water. What that means, the water can be used directly without much of further processing. It can be retrofitted into the existing plants. It can be operational within very few hours of the commencement, and then it has ambient temperature, which is suitable for the Indian conditions. And it's highly efficient, modular, and integrated approach, very low footprint and low carbon footprint. So there are a lot of advantages in this technology, indigenously technology, a made in India technology, which can be of agreements used to all municipalities and other people, institutions who handle wastewater. And let me tell you, municipalities like Surat are actually generating a lot of revenue, much more than what is required for pumping of the supply of the good water in the city. They are generating large revenue from selling of this treated water to the industries. So this is the model of as a revenue generation model has to kick in, so that the municipalities and the water handling bodies in the municipalities are nurse back to health, and then the water supply can be ensured. So I am not taking much time on technology, because technology, Dr. Nupur Bahadur will be explaining to that. She is a working fellow in the TERI, the Energy and Resource Institute, Delhi, and her expertise, as I said, is involved in advanced oxidation nanotechnology for wastewater treatment. She is a PhD in chemistry from IIT Roorkee, and also vice chairman of the International Water Association India. Her research have brought in a lot of award for herself and for the institute. She had got the award for design and manufacturing technologies for Make in India in 2015. Outstanding Women in Science Chemistry Viva 2018 award. ST 2010 for technological innovation in wastewater treatment. Aqua Foundation's Excellence Award in 2019. Department of Technology. ST Meritorious Award in 2020 for excellence. A list continues. So she and her team has developed wonderful technology which is suitable for the country, which is a truly made in India product. Over to Dr. Nupur Bahadur.
Thank you so much, sir, for your kind words. And thanks a lot for giving me a chance to present my work. And here I share my screen. So here I am for the 7th Water Tech Talk, and I'm really thankful and grateful to National Water Mission for giving me a chance to present the work which has been developed in last few years. And this is nothing great or very big achieved so far. This is just a proven concept and to a pilot scale which we could have achieved with such an innovation in this sector at this stage with limited resources and funding. So from here, I think we have to move ahead. So here, this technology, the title of my talk is TERI Advanced Oxidation Technology, which we call TEDOX, to treat wastewater and enhance water reuse. So as rightly said, so my talk will be primarily, I'll be dealing with the first, of course, the vision and mission of our group. And then we have to understand what are the current treatment gaps and what are the challenges which we are facing in wastewater treatment. And then next we'll come to the water reuse, which is the key priority of not just the government, it should be for all of us, how to enhance water reuse, how to reduce, recycle. So when we talk of water reuse, what are the key requirements to enhance water reuse? Then secondly, we have to pause and think how well we are prepared. And then we have to explore possibilities from whichever source we get water, how to enhance the water reuse efficiency. So that is the main component of the platform. Then comes the role of advanced oxidation. What is generally an advanced oxidation technology, and how has this TEDOX come out as an innovation? Then I will be discussing through this platform the works done so far from this platform. So here I'll be dealing with 4 scenarios where we can enhance water use. First will be the industrial wastewater. After treatment, how can we enhance reuse? The second category is very dedicated on difficult wastewater streams, where advanced oxidation is really required. Then comes the municipal sewage wastewater, which is not at all a difficult wastewater stream, but still it is considered when it is a complex stream when industrial effluent mix into it, and when we are talking of water enhance, treated water enhance for reuse. And the 4th category of work will involve how we can improve the quality of water treated through wetlands. And the most important, the open drains, if we can do something about the non-point source pollution as well. because all this work covers prior to this is the point source pollution abatement. So his fourth category will be exploring these options. So then we will go to the tangible and intangible benefits of this technology. Techno-economic feasibility we'll assess. And then comes this, what has been the outcome so far for last 3 years from this technology platform. And then we'll discuss the way forward. So this will be the broad contour of my presentation. Now coming first is the vision and mission. And today through this platform, I would really like to tell that what inspired me to be here and work dedicatedly for this. Very briefly, I was into teaching and research, just like normal teaching faculty with research and publishing papers and nothing beyond that. But I was highly inspired by 2014 when this Namami, when the Clean India and Namami Gange program was launched by the Honorable Prime Minister. And today we are talking of Jan Andolan, but in 2014, I struck the chord with it. And then I thought, how as a scientist, how as a teacher, then I was purely into teaching and research, how can I contribute in this big mission? And so then from 14 onwards, I began my journey. And whatever has been achieved so far the beginning has been after visiting wastewater treatment plants, sewage treatment plants, visits to the industries, knowing the problems and on ground, what are the problems, what industry needs, and where and what intervention could change could be a game changer. So 14, 15, I really studied a lot, worked a lot, and from my journey today is from a chemist to a photochemist to a nanotechnologist, material scientist, water technology, and today I'm working on water process engineering and learning. So it is continuously a learning process for me as well. So my vision is there to contribute as a scientist in nation building and in missions of national importance like the Namami Gange, water conservation, Jal Jeevan Mission, and self-reliant India. So a technology developed, made in India is purely, and we have to take it forward from here. So the mission, the whole idea about this technology platform is to develop integrated approaches, because what I believe is that no technology is a complete solution to any one problem. We have to have integrated approaches in problem solving and find the rationale for each and give the space to each technology in its domain. So the idea is to have integrated approaches which curb point source pollution, help achieve ZLD in a much affordable, sustainable, resource and energy efficient manner, and enhance treated water reuse efficiency. So this is the idea which goes behind each and every work what we do through our platform. So here you can see this is my inspiration, the slide taken from National Mission for Clean Ganga in 2014, and this has been my inspiration. And I have identified the aim for myself. This is the point source and non-point source. Then initially I was into industrial wastewater treatment. Now we have moved to municipal as well. Initially it was just point source. Now we have moved to point source as well. And here you can see the target. The difficult wastewater streams are the ones which are the 17 as per the ZLD. I just briefly tell you about ZLD. It's a concept which came through CPCB guidelines in 2015, which generally I'm talking about because having an audience across different domains. So in simple words, what ZLD means is that we have to we cannot dispose untreated water through our premises. It has to be zero liquid discharge. And also the treated water should be treated to such a quality that if we can probably reuse in the process, low end or high end, but it should not be going out of the premises. So it is this ZLD, zero liquid discharge, which has stringent guidelines, and 17 industrial sectors have been identified as most polluting. So those are the ones we have chosen. And also, as you can see, the modern day sewage also comes, it needs advanced treatments. When we talk of the nutrients, the organics, the micropollutants coming into the sewage. So ultimately, whatever be the stream, our target pollutant is the one, any stream having high color, high COD, TOC, the total organic carbon, pathogens, and POPs, the persistent organic pollutants. So this is our target. So with this, I move ahead. So current treatment gaps and challenges. So this is one slide, just one slide, and I would like to draw your attention that what ails our wastewater treatment. So first of all, you see in this slide large number of numerals, which means we have a large number of treatment stages. Secondly, number one is we go for the physicochemical treatment. So currently what we are doing in India, we are treating, making use of large number of chemicals and large amount of chemicals just for the physicochemical. That means the primary treatment to have the suspended solids settled. And then the second major issue, which I think, according to me, is the challenge is that in India, what we are doing, we are treating different streams with similar protocols without understanding the nature and constitution and the requirement of a particular stream or a particular stage of treatment. So these are two basic issues which we have to address. So here, our endeavor, our innovation starts right from the first, that with stream segregation. This is an example of a coloration industry. And here you can see stream segregation takes place, the high pollution, low pollution stream. And then for the high pollution, we just have some pH adjustments and we directly send the effluent for the ME, which is multi-effect evaporators for evaporation. For the low pollution streams, or you can say the MSMEs, which can afford some treatment, we go for the physicochemical, use large number of chemicals, and first the outcome is the sludge. You see the amount of sludge, which is highly toxic in nature, and it leads the management of sludge is in itself a huge problem. Then secondly, we rely on biological treatments, ozone treatments. So without realizing that a few industrial wastewater streams, biological treatment is a big challenge for them, but still we insist on having biological treatments. Then after that, we move on to sand filters, activated carbon, and this is a very common example. This is not to particular any stream, but you can see it's a very common example. We end up with this orange color water. So what we have understood with our work, that the primary treatment in which we involve a lot of alum, ferrous salts, they are the main culprits which remain insoluble and they lead to this kind of water. So this is what an MSME could afford and do. Any big industry who can afford tertiary treatment, so from stages 5 to 7 is the tertiary treatment, in which this kind of water goes to the RO. This is the condensate and the reject of RO. Just for the audience, that RO also have a few cycles, and you can see this is a reject from cycle number 3. And this leads to the choking of membrane over the time. And finally, this RO reject also goes to the ME, multi-effect evaporators, for evaporation. And not just this, ME also has its reject. So just imagine, and this reject finally goes for the evaporation, drying in ATFD and all this. And finally, we are left with this byproducts, the salts, which are not pure, cannot be reused. And this is ultimately what we are left. So finally, what I would say, A is we are starting from A. We have reached B, which is the condensate of ME. So what we have achieved from A to B, we have definitely achieved ZLD, zero liquid discharge with desired parameters. But just imagine at what cost to the environment, what cost to treatment. So overall, when we see the treatment in this present stage, we find the treatment highly unsustainable. So with this, now, second issue of wastewater is currently what we have is the water reuse. So national policy, many states have come up with the water reuse policies, and now we are coming up very soon with the national policy on safe treated water. So what is it? So water reuse, we want to enhance. So the requirements are very stringent. You see, industrial treated water reuse options. If I start from low grade, these are the parameters: COD, chemical oxygen demand, and TDS should be this much. And then it would be applicable for horticulture, suppression, construction, and all. If we improve the water quality, reduce COD less than 50, reduce TDS less than 500, we are able to get the water for the cooling towers, scrubbers, for directly for the vessel washing, floor washing, etc. And if we further improve the water quality, make it high grade by bringing COD less than 10 and TDS less than 250, we call it high grade water, which could be used as a boiler feed directly in the process. Second is from the sewage. Sewage water, when we look for the reuse option, again we have the two options. One is the moderate or the low grade water, where BOD is less than 30, COD is less than 150, and this, which is used good for use in horticulture, this and that. If we further improve the water quality to BOD less than 5, COD less than 30, and this, we get the water for cooling tower and high-end applications. So this is the target. So those were the challenges. This is the target. And finally, if we look, I have just summarized with my understanding to improve water reuse, what we need. First of all, we need to remove hardness and TDS. Second is to remove COD and total organic carbon. And third, to remove dissolved organics, the POPs or the contaminants of emerging concerns or the micropollutants. Now, how well we are prepared? The next question is, for having the two issues in front of us, how well we are prepared. I'm an optimist, and I would say, yes, we are prepared we have the technology options to remove the hardness, TDS removal. We definitely have membrane-based technologies, which are working very well. And we have all these 4 with us. And you can see here with these are the port sizes, and this is the filtration. And we have things in place. We are ready for this. Here, this is just to show the audience that how does RO systems look like. These are huge structures, large number of RO membranes are operative. They have spiral binding. And this is the issue, the unclog, and this is the choke membranes as a result of treatment. Next is again, reject management. We are prepared. Again, as I said, we are prepared for reject management. We have evaporators, we have technologies. So what we are doing, we have 3 types of evaporators. So what are they? To evaporate the reject of the membrane processes and recovered salts, we have multi-effect evaporators with ATFT. These are called thin film dryers. So what, again, you see huge structures, and these could be affordable by the large scale industries or CETPs, and just see the amount of energy and the footprint they require. And this is the science behind it. Then what happens when you evaporate the rejects? You have to recover the heat which is generated in large amount from the steam in the NE. To recover that the steam, we have MVR, mechanical vapor recompressor. So this is the basic idea behind an MVR. And again, you can see the huge structures with MVR. Now coming to the organics, third category. To remove organics, the COD and TOC, we have biological treatment technologies in place, and they are running well. Again, I would say I would complement with the current system what we have. But now when we talk of enhancing reuse or improving the system, where comes the role of advanced oxidation processes? You can see here the COD. To have removed large amount of CODs, we have to go and advance, we have to go for the advanced systems. So here comes the role of advanced oxidation to enhance water reuse. And here is this scope. This is our trademark, which is accepted, and patent is pending. Now, what is an advanced oxidation process, an AOP? AOP is any technology or any process which generates hydroxyl radical. So depending on the source, if the source is chemical, we call it chemical AOP. If the source is photons, the light radiations, and the chemicals involved, it is called photochemical, like the phenton, photophenton, H2O2, UvH2O2, ozone, and photoozonation. If the source is phonochemical, then it is this electrochemical, and likewise, depending on the source, we have a large number of AOPs, and most of them are prevalent somewhere in application across the globe. What we have chosen is the photocatalysis, where we make, this is where actually I owe this to my own PhD. I did my PhD from IIT Roorkee in the area of photochemistry and photocatalysis, where from my PhD, I use the UV nanotitania based systems. I developed those systems during my PhD for some molecule, aniline, xanidine, for their degradation. And then in my postdoctoral research, I worked entirely on nanotechnology, synthesis, nanomaterials, absorption capacities, and improving on the materials. And today, as a third stage of my research, so to say, I utilize both my prior experiences of PhD in photochemistry and photocatalysis and my postdoctorate in nanotechnology. And at this stage, I am applying both my experiences in water technology for treatment of wastewater. So here the science is very simple, that we make use of nanomaterials, very specific kind of nanomaterials. They are semiconducting in nature, and in the presence of suitable UV light radiations, it is a natural property of a semiconducting material we all are aware of, that in the UV light excitation, these electron and hole pairs are generated, and in the presence of oxygen, water, and all these hydroxyl radicals are generated, which means in situ, we are generating these hydroxyl radicals. To generate this radical, we are not using any externally added chemicals for the purpose. For ozonation, you need an ozone. For any chemical, photochemical, you need a chemical along with the photons to get this. The beauty of this work is that it is, if we switch off the photocatalytic reactor, the reaction stops. When we switch on, it starts. No incubation period is required for this process. And it is ultra fast. So this is the benefit and the beauty of this process. And the hydroxyl radicals, when they are used, this is one example from my own publication in Carbon, that when they are used for oxidation, what do? They are oxidatively degrading the complex dye molecule or any pollutant molecule into small molecules. And ultimately, it is leading to the mineralization. You can see here, the complex molecule or the pollutant is broken into minerals. This is where our current treatment technologies are lagging, where they are not treating the pollutant, they are converting the pollutant from one form to another. Now, with this simple science, we have applied this simple science in the real wastewater treatment scenario. This is this. And first of all, I would acknowledge that this technology was developed under DST Water Mission, Water Technology Initiative Program of the Ministry of Science and Technology, Government of India, through a funded project from just 2017 to 2020. So it's such a new effort, a novel effort done in recent years only. So the novelty features is, first of all, that we have similarly primary, secondary, and tertiary treatment, because science remains the same. It will not go. But only thing is we have to think differently. So the two novelty features remains is that we have involved advanced oxidation, AOP-based nanotechnology in our secondary treatment stage. And second most important, the innovation is that no biological treatment is taking place. So direct TEDx treatment involves the first stage. Here, the innovation component is we are not using those alum ferrous salts. We have come up with very novel formulations, proprietary materials, to reduce the TSS up to 90 to 95% right in the stage one. And once the matrix is clear, we are applying nanomaterials, giving contact time, aeration, and passing through a photocatalytic reactor, having a suitable geometry, radiation, and all. And here, after this nanomaterial, after particular HRT, hydraulic retention time and treatment, the nanomaterial is recovered right at the source, and TEDx treated water is until here. Now, if required, because we are targeting the organics and the TOC and all, if required, the TDS is almost 40% we are able to reduce. But if to get further reduction, we may go for tertiary treatment involving RO and NE. So this is the simple process diagram, I would say. And based on this, now the benefits, I would say, for the TEDx, first of all, it's a clean and green technology. Why so? I've already explained, because we are utilizing intrinsic property of nanomaterials to generate radicals. No external added chemicals are used for this. And the hydroxyl radicals which are generated are having this oxidation potential, and this is 10⁹ times faster than oxidation through ozone. So therefore, you will see in our treatment results, the treatment is taking place within few hours. So this is first benefit. Second, we are able to completely oxidize, so complete mass balance we are able to achieve it. So less sludge, no secondary pollution, and complete mass balance is achieved. Third is, since hydroxyl radicals, they are non-selective, which means being non-selective, they can target a large number of molecules, which means a same technology, a same simple technology, it could be applicable to a large number of effluent streams from different industrial sectors. So this is another benefit. And fourth is the UV irradiation is taking place along with nanomaterials. So we all are aware of that UV radiation leads to bacterial inactivation, disinfection, anti-biofouling, and this is the reason we do not require biological processes, because this component is taking care of this. And last is the waterborne pathogen inactivation we all are aware of, and this is the call for the time when we have to see our water is also safe and healthy. So now with this background, with this introduction, benefits and all, I'm coming to the 4 case studies and the work which we have done. Humble work, I would say. This is just an endeavor to establish that yes, this is possible, something is working, establish a 10 KL plant is operational in TERI Gwalpari campus. So this is the message I would like to give from this platform. So here are the studies. First is the industrial wastewater. So first in this category is the coloration industry. Particularly, I'll talk about textile wastewater. And here this is an effluent we obtained from a cotton and dyeing industry from Andhra Pradesh. And you can see, I hope you have understood the process. So we have a very simple 2-stage process. So this is the real effluent. This is the post stage 1, after stage 1. And then this is TEDOX treatment. We are getting this water directly, and the treatment time is 5 hours in this process. And when we studied the sludge residues, you can see A, B, all these components. A is the amount of the sludge, so-called sludge residues from this particular study. We have gone with the elemental analysis, and what we see majorly it is but the hardness of water which has come out. And we have also done the TCLP studies, the toxicity studies. So this is found to be non-toxic. And the water quality parameters, if you see here, what is we are achieving actually these ZLD, and this is the result. So with this study, this is from an individual ETP. So with this study, what we propose to industry is that for individual units in a coloration industry, we can directly go for TEDOX treatment, and the water is sufficient enough for direct reuse. If required, then go for tertiary. Otherwise, water is 50% available for direct reuse. In case of a CETP, now we are working very closely with CETPs, the common effluent treatment plants. So here, this is a case of a CETP of a textile cluster from Jaipur, Rajasthan. Here, this is our CETP where 17 units are bringing their effluent to a common effluent treatment plant after their primary treatment. So here also we visited the site. We did a number of work, a large number of experiments were done at different stages. So finally, we went with our successful formula of treating directly. This is a raw effluent from the equalization. This is our stage 1 treatment, and this is TEDOX treatment. Direct, you can see, and just see the spectra, and these are the water quality parameters. We don't do testing. All these lab certificates results are NABL lab certified test reports we obtain. So here again, you can see. So now what you see, what is the difference between the first and the second is that when we go for a CETP, what we are seeing that BOD by COD ratio, which is an indication of improved biodegradability. So here BOD by COD ratios have improved, which means now this color has gone, COD has reduced to substantially, but further it needs treatment. BOD has reduced substantially, but still it needs treatment. So now this water, TEDOX treated water, can go for the existing biological treatment which the CETP is already having. So what we propose in case of a CETP, this TEDx could be integrated in the current treatment system in order to improve biodegradability, to remove COD and color right there after the secondary treatment, so that the load on tertiary treatment stages could be reduced. So this is our outcome. So now when we treated the same water, the last CETP treated water, when we treated with other advanced oxidation technologies, as I mentioned earlier. So these are the results. With the same treatment time, these are the results. You can see from photofenton, UV-H2O2, UV alone, this is TEDx treatment. And here you can see a very special case when we have reused nanomaterial up to a large number of cycles. So now we are able to recycle our used nanomaterial up to a large number of cycles. And this is the water quality with the reused material. We have also been a research organization primarily first. So we have gone with the nanomaterial characterization. XRD was done at IIT Roorkee. And here you can see the same, the material, the crystallinity and the phase of the material remains intact, which means the nanomaterial is not affected. And hence we are getting the same properties and the water quality parameters. Also, we have done the sludge characterization, again, elemental analysis. This is what we are getting in the current treatment of the CETP, and this is what we are getting with our intervention. And as I said, we are getting low sludge generation ratios, and as per the TCLP studies, it is safe and non-toxic. So now I'm coming to other industrial, what we have done. So that was one study I have explained in detail. Now I'll not go into details of further studies. So I'll just be emphasizing on the sectors which we have touched. So here you can see TEDx could be, so based on our work, what we have done is we have characterized the TEDx treatment as per the requirement. We can use it at a pre-biological stage for streams which have high COD, which means high pollution load. First go for TEDx treatment, improve biodegradability, and then go for with the existing biological system, whatever you have. So this is the first example. This is a highly phenolic stream we obtained from anisole plant of a chemical industry in Gujarat. And here you can see the COD, the 160,000 COD has been reduced to 16,000, which means the 90% COD reduction with improved biodegradability of 4 to 5 times. Now, instead of this yellow color water going to the biological, this water, this is actually water, that is of course not water. So now this water going to the biological system will help in further reduction of the parameters. Second example in this category is, this is the water we obtained from injection water from oil drilling sites in Gujarat. So what happens, this is an example of a produced water from an oil and gas industry, where with one gallon of oil, we get almost 20 to 30 times the water, which comes with very high pressure and which is highly polluted because it is coming from deep from the injection wells. So this is the water. And after direct TEDx treatment, because this is clear, matrix is quite clear for the photocatalytic effect. So therefore, direct TEDx treatment for such a stream. So here we are obtaining the parameters, and this was the first time done. And now this is very interesting again. Now this is the categories change. You can see it is post-biological. So for streams, we have to understand that for streams which have very large BODs, for example, distillery, dairy, paper and pulp, what we can do, we can go with the conventional biological system, and after biological, we can go for TEDx treatment to remove the lignin, the melanoidins, or the dissolved organics in them. And this is particularly, we received this tertiary treated effluent from a pharmaceutical company in Uttarakhand. And this was the water which was being discharged into the Ganges. And here, this is our direct TEDx treatment in just 3 hours. And this is the water quality. And one important feature I would like to highlight, that ammonia and these parameters which were not detected in the pre-treated sample were detected in the post-treated sample, simply because now the complex molecules are broken and it is detectable. Now coming to very quickly on the tannery. So here tannery, this is the category 2 after post-biological. This is an effluent from a tannery wastewater from a tannery industry in Kanpur. This is biologically treated water, but you can see the issues color remains and COD is there, and hexavalent chromium is also there. So for tannery, we propose that after probe separation and after biological separation, we can go for direct TEDOX intervention. And here you can see the water quality parameters. This is an effluent from a tertiary treated, means, and last two cases, this and this, I would say you can use TEDOX at a post-biological stage or at a polishing stage. This is an example of a slaughterhouse in UP. This is the finally treated water. You can see COD is less than 50, but color is still not going. So for such a stream, we can have TEDOX at a polishing stage, and just 2 hours polishing, and the water quality, the COD is reduced below 10. What else we need? So that was all about the industrial wastewater, a common industrial streams. Now I come to the difficult wastewater, actually, which really needs the advanced oxidation. And these are those difficult streams which the company comes and tells us that we have tried all existing technologies, and then we are coming to test TEDOX. This is the stage. So therefore, I have specifically kept these 3 cases as a separate category of difficult wastewater. So this is a distillery slop ME condensate. Now I'm coming to the difficult wastewater, the ME condensate. What do you do with it? So if we have to achieve ZLD, we have to think of the ME condensate. So this is our intervention. And this is a very recent study, last 3-4 weeks, the study is from, and we have to further, of course, as I repeatedly, I will say we have to improve further, but here this is what we could at least establish that this is possible. So here you can see distillery slop, ME condensate, ATFD condensate. These are the real issues in achieving ZLD, which industry and big industries which face, this is, see, the color is not going, COD is very high, it cannot be disposed of. And currently, very sorry to say, and from this platform, I would like to say that we have to have stringent regulation, and industries, they have to be very responsible, and they cannot discharge their untreated or such kind of water into sea or other sources. Last in this category is the ME condensate. You can see here the color, the COD, and here this is what we achieved. So ending the first 2 categories, when we compare our technology with not just cost and efficiency, we talk about overall sustainability, and in terms of cost, efficiency, clean and green approach, overall secondary pollution and sustainability, we find ourselves here. And these are all the industry validated results. We have validated ourselves with other technologies in all these scales, and here we are. Now coming to the municipal sewage, and here comes the innovation, and I'm very glad to share that municipal sewage, which is considered a very simple stream. We have been, for ages, we have been treating municipal sewage using biological processes and all, and fine, things are going fine. But as I say, the problem, what are the challenges? When we talk of modern day municipal sewage, it is not just sewage, because the plants, STPs which were built, they were long back, and they were built as per the sewage of that time. But now when we are talking of modern day municipal sewage, it contains not just the sewage, it contains the untreated or partially treated industrial effluents. It contains the POPs, the micropollutants, the various drugs, runoffs, which are mixed in the streams. So therefore, it is a complex stream, and therefore I have kept in the study. And again, the third issue is that when we talk of sewage, it has less shock bearing capacities. The STPs have very less shock bearing capacities. The treated water find use mainly for water. We cannot think beyond horticulture, and we are very happy about it. It is good. What we are doing is fine. But again and again, I'm saying my whole endeavor is to enhance water reuse for high-end application as well, if we can, if it is possible, as it is, we can see possible here. So here, and now the current treated water, we are definitely using for horticulture, for dilution here and there. But how the water quality testing has to be robust, and we have to see that whether it is hygienic, the water is healthy, which is going for even horticulture or agriculture or gardening and all. So in unfit for high-end application, as I said, and unfit when required for, we need the high-end application and reuse. So here I will just show one case study. We visited a common sewage treatment plant in Delhi. We don't name any industry, we don't name any organization. So here, this is the whole idea is just to present the case. So here you see, this is a raw sewage. This is on the left corner, you see the raw sewage of a sewage treatment plant in Delhi. And we studied this in terms of biological parameters, microbiology parameters, physicochemical parameters, and micropollutants. And I'll show in 4 slides. The innovation component, first and the biggest innovation component, first you see here, on top is the current treatment which is taking place. And this is using conventional technologies, ASP-based technologies, then passing through filters and all. So this is conventional, which takes this much time. So what we did, with our experience on industrial so far, we tried our science on sewage. So there are 2 possibilities we explored. First, whether we can polish the current treated sewage, which we did on the top right. We use TEDx, direct secondary stage TEDx on the treated municipal sewage of the CSTP. And this is what we get, 3R treatment, post-biological at a polishing stage. Then we thought, if we can do, let us try to do directly the inlet. And here at the bottom, you see, we treated directly the inlet of the sewage, which means no biological treatment, which means the time of reduction, just imagine. So we are saving on the time, we are saving on the footprint, the resources, the efficiency of the overall treatment has tremendously improved. So with this, what I would humbly submit is that for the existing sewage treatment plants, we can go for TEDx at a polishing stage to enhance water reuse. And for the newer projects, we can go for direct TEDx implementation at the inlet. And you can see the water quality parameters. BOD less than, next it will come. Here you can, these are the biological parameters. This was the work which we done. We saw the presence of SARS-CoV-2 in the raw sewage. And of course, this treatment plant is running well, and no SARS was found in the post-treatment, and obviously not in TEDx. Second is the physical parameters. If we see pH, color, TDS, TSS, and total solids, same thing, the same approach. Polishing, TEDx polishing at the treated, and direct TEDx treatment of the inlet of the sewage. Here and the water quality parameters. This is the chemical characteristics. 3rd slide, and same thing, but the parameters here you can see here. So this is what is being currently treated in percentage terms. Here you can see the TEDx treatment at polishing stage as compared to the inlet. And here this is direct TEDx treatment. So when TEDx is giving the similar results as in polishing stage after post-biological, so why not to have TEDx as a direct inlet? So this is the innovation which I really would like to take it forward. And the water quality parameters, BOD less than 5, COD is there. Further with time we can improve it to, it will come below 10 as well. Micropollutant, this is a very important component because in India we do not have any prescribed limits for micropollutants, whereas a few European countries, they have come up with the legislature on that. So from this platform, I would also like to appeal to the government to work on the micropollutants limits. And here you can see, we have chosen the most common micropollutants which could be found and which are reported. And these are different classes of micropollutants. One is the common, very common. These are amongst different micropollutants. And the same approach you see here, the current treatment, which is leading to these parameters. This is TEDx treatment, which is removing a few micropollutants up to a non-detectable limits, you can see. So this is one case study of municipal sewage. And as I said earlier, this is the real innovation in the space of sewage treatment. Fourth and last category is the wetlands. See, wetland, the treatment, it is very good, very cost effective, and it is fine when we have large spaces and things. And for a country like India, if it is possible, we should go for such wetland approaches. And again, there is no harm. But again, when we come to enhance water reuse, so we thought that if we could possibly enhance the water quality of the wetland treated water. So with that endeavor, we did this study. And fourth problem, identified problem, is the open drains. So here, our own Terry Walpadi campus, we are having it's a huge 100-acre green campus. We have research labs, we have retreat facility, golf course, cricket ground, student residential facilities, hostel, canteens, everything. And we have 3 sources of wastewater, and they are treated using 3 different sources. One of them is the root zone treatment. So here you can see the root zone treatment is taking place in large area. And this is, we all know what happens in a root zone treatment. What we did, this is the RZT, root zone treated outlet water. And again, direct TEDx treatment we used. Here you can see the parameters, RZT inlet and inlet which is going for the root zone treatment. And this is the root zone treated water. And this is the direct TEDx treatment which is taking place. Again, the physicochemical parameters you can see, the microbiology parameters you can see, and of course the micropollutants. So here we can see that wetlands or root zone treated water is able to achieve to some extent, or probably it is not being effective for micropollutants, but you can see the TEDx treated water can be a solution to enhance water reuse for a wetland treated water. Fourth and last study is an open drain. So this is a very common problem we face in a large number of places in India. A drain is passing through any campus, a residential colony, wherever you see. So it is not just an environmental hazard, it is a health and occupational hazard as well. We have to understand it. So what to do? So with that point, what we did, that we studied, this is again a drain passing through our this, and we got this here. So similarly with this is the effluent of an open drain and directly the TEDx treatment. Here you see. And untreated open drain, just imagine the parameters. These are the parameters, microbiology and the micropollutants you see. Just imagine, these are beyond imagination. We are having in an untreated open drain, and what we all know, where this water is going. So many people are using this water with minor treatment or no treatment, and what we are doing with our health and environment and sustainability. And the direct TEDx treatment of such micropollutants, just see the parameters. So all were the case studies. Now I am concluding my work with tangible and intangible benefits. So when we compare our technology as a decentralized treatment option in municipal sewage, we find we compared ourselves with all existing decentralized wastewater treatment technologies. We find ourselves, this is a reference, I missed it mentioning here, this is a reference from a CSE report, and we compared our data with the reported work. So in terms of efficiency, BOD, COD, color and turbidity removal, we are here. In terms of treatment time, we are here. In terms of footprint, we are here. In terms of power requirement, we are comparable. And with whom we are comparing? This is important. We are comparing with the best in the existing scenario, the MBR. The water quality MBR, the water quality obtained from an MBR. So we are comparing our water quality with this system. So here we are comparable in terms of power, but other benefits you have already seen. When we compare, these are the estimated costs. And once TEDx is applied somewhere, then we can get the realistic figures. But definitely, this is the validated data with the existing. We see ourselves the capex is 20 to 25% reduction, and OPEX is 30 to 40% reduction when we use TEDx for this treatment. Now, looking at the benefits, so I would just say application areas are wide. Science remains the same, technology remains the same. The application areas, we just started with one project which was granted for textile treatment, textile wastewater treatment, but we could do so much from this one small project that we could test the current, so to say, in large number of streams. And then the clean and green approach, you have seen very limited use of chemicals, negligible and non-toxic sludge, no secondary pollution, or limited secondary pollution issues, I should say. And disinfection is already taking place. Water quality, we are able to achieve ZLD, we are able to achieve surface discharge water qualities. And in many cases, in case of municipal sewage, we are able to achieve CPCB class A grade water as well. So efficiency, you can see in terms of time, treatment time is few hours, really resource and energy efficient technology. And why energy efficient? Because it is helping to reduce the load on tertiary treatment. Therefore, it is energy efficient. Then, of course, the low capex and OPEX, as I have stated, and small footprint, it could also be. It could be retrofitted at larger scales of 500 KLD, MLDs and all. Also, it could, because reactor modules are there, so it could be taken at small units also, 50 KL, 200 KLD. This way also we can work. So therefore, it is a modular, integrated and retrofittable technology. It could be used in existing systems and of course in newer projects. And it could also serve as a decentralized treatment options in green buildings, township, commercial spaces. So if we have to pitch into the Ministry of Urban and Housing and Urban Affairs, so here is our submission that this is a sector which could be looked upon with this as well. Then compliance with criterion 14 of the Griha manual, which is of course a product of TERI. So 5-star rating is given based on some criteria. So such a novelty component could also add a rating in your Griha. And of course, in smart city projects, this could be integrated. Now, so the whatever has been developed in last 3 years, with this outcome, TERI from 1st April 2021, I'm glad to share that we have a dedicated new area within Water Resources Division of TERI, which is called TEDx Technology Center for Water Reuse. So now with this platform, or I could say for last 3 years, our work has, all this, whatever I presented are the published, peer-reviewed, international published results. You can see latest publications with high impact factors and citations as well. A very important aspect we are also studying, I would like to tell you, it's not just about water treatment and reuse. Being a responsible scientist, I also have to see that what is the use of the nanomaterial which we are using, how good is the quality of our treated water. So for that, one dedicated PhD is on the eco-safety aspects of plants and aquatic life. So we are treating our TEDx water, TEDx treated water in plant growth, horticulture. Plants are growing well. And also the Daphnia magna survive, which is a CPCB requirement for seeing the effect. So this is also, and this work is yesterday revised manuscript submitted in Environmental Science and Pollution Research. These are the media articles, and we launched our technology in September 2019 and completed the work in 2020. These are some recognition and awards for the technology. And this is the 10 KLD functional TEDx plant in TERI Gwalpa in Gurgaon campus, recently inaugurated by our DG. And we are really honored that we got great encouragement, and this technology was presented in the India Water Week in 2019, and from that platform, this technology was chosen and encouraged by NAMAMI, National Mission for Clean Ganga. And we were given a few sites. We went there, worked there, presented our findings, and we have recently signed an MOU with National Mission for Clean Ganga to have pilot demonstration, to start with pilot demonstration across a few sites in the Ganges Ganga belt. Recently, we did an online training and capacity building certificate program on treated wastewater reuse. So just finished on 22nd March. And on World Water Day, we also came up with our first policy brief on TEDx to treat textile and dye wastewater. And these are R&D based policy recommendations. So what we have done, the whole idea about this policy brief is that we have done work for a large number of industrial clusters. So now, maybe due to COVID and all, industry needs some kind of financial support to have pilot demonstration of TEDx at a larger scale, let's say 100 KLD. So to bridge the gap, they need the financial support. So we have come up with some policy recommendations to Government of India, where the technology provider like us and the technology adopters could be given a platform. Then, this is my second last slide. Acknowledgement is the most important part of any work. I would like to first acknowledge my alma mater, IIT Roorkee, from where I earned this knowledge. And then comes the Ministry of Science and Technology, Government of India, where I have done 2 projects. DST Young Scientist Project, where I did work on nanotechnology as my postdoctoral research. And then just recently finished project through DST Water Mission. Through this technology is developed from that platform. Then NMCG, as I said, we are thankful. Delhi Jal Board, we are working very closely with it. ONGC Energy Center was our industry partner in DST project. Perfect Group is the one who is our advisory. And all the samples which we could get, just imagine, which is not possible. This is the support. This is an MSME company which has adopted TERI advanced TEDx technology to take it further. So this is, we are thankful. And of course, we are thankful we have not named any industrial partner or organization and here for providing the affluence and presenting this. And then comes my team, the TERI management right from top. I'm thankful for the support of the management and all concerned. And then my brilliant team of research scholars, very young lads. And I hope their smiling faces says it all. And finally, this is my last slide before thank you. I would humbly like to submit from this platform that this work came from a passion of a scientist which understood, after understanding science, innovation has gone into it. And with an interdisciplinary team, a technology is developed. And here interdisciplinary team, by this I would like to say that in my team, we have chemical engineers, biotechnologists, chemists, material scientists, civil engineers, so environmental scientists. So this way, our team is an interdisciplinary small team. And after this, we really need government, academia, and industry support, which we have got to some extent, and we have reached here. We are thankful. But now, if we want to go ahead with our missions to achieve the missions, Clean India, Namami Gange, Make in India, Startup India, finally the Atmanirbhar Bharat, I really want to contribute in this. We need support from the government, from industry, big industrial houses with their CSR funding. I want the engineering and manufacturing companies to come ahead to take this technology for implementation, upscale, and fabrication and all. So this is this. Finally, thank you so much for the patient hearing. And again, National Water Mission for giving me a chance to present my humble work at this platform. I am stopped sharing the work.
Thank you, Nubuji. Fantastic presentation and really exhilarating, and I'm excited to see your presentation, and it has brought out a lot of advantages. But only thing is that I probably missed out. You didn't point out any disadvantage or anything. Everything seemed to be very rosy. It is very good. You have done excellent presentation, and the effort is really good. And you compared your technology with various other technology and at various stages also, and it really is a very eye opener for me at least. I hope that a lot of participants who are here, I've seen a lot of water companies also in the participants here in the main presentation as well as in the Facebook presentations watching your show. So a lot of technology companies are also there. So I hope that they will definitely take notice of your technology. And it's amazing that this can really make a very big change in the cleaning of the wastewater with very low footprint and very low cost and very low damage to environment. This is all plus win-win situation. I would say win-win-win situation. I hope that this we can push it through to the policy planners so that they can start implementing it. I also thank Namami Ganga for giving you this opportunity to have a pilot project, because what may look good in the lab may not be successful in a big project. So it's good that the Namami Ganga team has given you opportunity to showcase this in a bigger pen, Dinapur plant also. So I had been there myself as ED projects there, and that one plant which has which attained the self-sufficiency in power generation also, because it's a zero power consuming unit also. So this type of technologies, if we can utilize and make it functional, then it go a long way in energy stability as well as for the environmental of the country. Thanks a lot. Now the session is open for questions. I am sure there will be a lot of questions. Please, take it up the question session.
Thank you, Ashok sir. Like Ashokji mentioned, we are officially open for the Q&A. All the people who have joined us for the very first time, I would like to share that there is a screen, like in front of your screen, there is an option of raising hand. If you have any query, please raise your hand. Our team will unmute you, and then maybe you can put forward your query after introducing yourself. So now we are open for the Q&A.
I request Mr. Rikesh Mehta, you may please ask.
પાણી અને શાકભાજી કે વેજીટેબલ્સ તમે જે ખાઈ રહ્યા છો એના લીધે જ આ થાય, અધરવાઇઝ ના થાય.
I request again Mr. Rikesh Mehta, you may please ask your query.
ફાધરને બધાને કેન્સર હતું. એટલે આ વસ્તુ એવી છે.
I request Mr. Jatin Mehta, you may please ask your query.
મમ્મીને તમે
I request everyone to kindly mute yourself.
I request Mr. Jatin Mehta, you may please ask your query.
Okay, so there are certain. Yeah, hello.
Am I audible?
Yes, you are. Please go ahead.
Yeah, good afternoon. And Dr. Nupur, it was very interesting and very innovative technology which you have worked on. And the case studies what you have shown is also quite impressive. I belong to a company called Technova Imaging Systems Limited in Mumbai, and for our chemical plant, we have the effluent. The volume is very low. In fact, just 10,000 liters or 10 KL per day. If this is a better technology, we would like to switch over to a simpler technology as what you have been talking about. So how do we move on that? We can discuss all the details once, if I can meet offline and discuss.
Sure, sir. Thank you for the interest and understanding. And definitely 10 KL, since we are already working at the 10 KL pilot, so this is doable. And further details we could discuss online. You please write to me separately. and I'll get back to you. Thank you.
Okay, so there are separately a couple of questions which have been sent via chat. And one of the questions which is by Shubham Kela, he's saying, what is the future of, he's asking, what is the future of membrane bioreactor in India?
See, membrane bioreactor is already working well, and it has a great future. Our only intervention is to help membrane-based technologies to enhance their lifespan and reduce on the operation and maintenance. So MBR has a great future along with TEDx at a pre-biological or accordingly at a suitable stage. So both have a great future.
There is a question from Mr. Paritosh Tyagi, and first of all, he is congratulating you for this commendable work. And then he further says, will it be possible to include heavy metals in the target pollutants, since tanneries and electroplating are in the list of difficult wastewater management sectors, basically?
Yes. First of all, thank you so much, Paritosh Tyagi sir. In fact, he is our guru. I know him very well. He has guided us in our work. So basically, he is there in our team, I should say. And as suggested, sir, currently we are focusing on AOP-based interventions for the color and COD issues and for water use. Regarding heavy metals, as I said, in case of tannery, we have to be actually very selective, or we have to carve a niche because we cannot get into everything and every industry. Since heavy metals, as in case of tannery, we can have TEDx intervention after chrome recovery and biological treatment. So if TEDx will come at a later stage. So here we have to understand where it is implementable and integrable. But definitely, as per his suggestion, we'll explore more for the electroplating because we haven't received any effluent. So we would like to explore the electroplating industry in future. Thank you, sir.
Now I request Mr. Chekita Hombali, you may please ask your query.
Hi, very good evening. And first of all, I would like to congratulate on this excellent work by Dr. Nupurji. My question, Nupurji, I have gone through your presentation, and there is a presentation. You have shown that there is a air blower that you induce in the nanomaterial mixing tank. And is it for breaking the COD for the oxygen? And second is the nanomaterial which is recovered. Is it sent back to the mixing tank? And what is the life of this nanomaterial?
Yes, sir. Thank you, sir, for your compliment. Coming to the three questions. First is when we are using the blower for the secondary stage, the nanomaterial has to be given the contact time and aeration because this is in itself a science where you have to have a suitable pH and the DO levels. So that is the purpose. And of course, the mixing of nanomaterials has to take place, otherwise nanomaterials will settle down. So this is one thing. Second question is regarding the nanomaterials. So we are at the current scales, we are taking our nanomaterial, recovering, regenerating, and reusing nanomaterial up to a large number of cycles. And as you have, third question is about the lifespan. So what we are currently experiencing is that with some top up, we are able to work with the same nanomaterials with same efficiency up to 2 to 3 months in case of sewage, very easily. Thank you.
Now I request Mr. Kuryachan Jose, you may please ask your query.
Yeah, good afternoon and good evening. So I'm from Middle East. Basically, I'm a chemical engineer. First of all, I thank and congratulate Dr. Nupur Bahadur. I think it was a great insight. I appreciate the national missions for water conservation and cleaning Ganga, or any other initiatives, which is to be my perspective, it has to go to the schools. I think you should proclaim and announce this from the industry level to the students, which could reach out to the homes, individuals. What is the importance of save water? From as a children, as a student, they should keep this strategy from their childhood. And again, Anupama, thanks for hosting this and balancing the webinar. But one of my major concern is that why we are only focusing on major like Ganga mission, or why? Because we have n number of rivers which can be recharged. See, Ganga, it's a costlier. I think we are touching only the costlier part of saving water. So we have many chances. There are n number of rivers, small and big, and major ones, and there are a number of ways we can save this, and it can be each states can be sustainable. Each states can be sustainable in their own ways instead of making a global mission. Global mission is very important. We have to have wastewater treatment plants. We have to improve municipal treatments. It is all well appreciated, but from my standpoint, I think it should locally, like panchayat level, jilla, district level, we have to proclaim this. What is the importance? Which are the rivers can be recharged? Which are the wells can be recharged, or the wetlands can be protected?
Yes.
Thank you so much.
Let's confine to the discussion here, because today's discussion is a water tech talk. It's essentially related to the technology and related issues. So if you can have this, we have a water talk which comes on every third Friday, and we bring in people who are doing ground level work at the village level. We have people who have done works at the different rejuvenation of different rivers, rejuvenation of different ponds, religious temple ponds. All sectors we are covered. So kindly, I hope you have seen the video which we had played in the beginning. That's why we made the video also. All areas we are covering. We are bringing in activists. We are bringing the theoreticians. We are bringing academicians in different segments. So today we are confining to water talk technology. Please come and join us for a water talk on next Friday. You may listen. You can hear what we are doing in the rivers and ponds. And second, we also have every Saturday we have a talk with the dialogues with DM, where we bring in 5 district magistrates and 1 NGO, where they share their works which is done in the districts. And otherwise, if you have missed all these things, come and look at our website nwm.gov.in, where we have placed the video links of most of these talks. You could see amazing diversity of topics, right from lake regeneration to small pond rejuvenation to river rejuvenation, water conservation. A lot of activities are there. Please have a look at that at the website nwm.gov.in, and you can see a lot of things. Thank you. Let's confine to the topic of today's discussion.
Now I request Mr. Amujuri Vishwas, you may please ask your query. I request again Mr. Amujuri Vishwas, you may please ask your query.
Hello. Am I audible, ma'am?
Please go ahead.
Yes, sir.
My question is that what are the new opportunities to conserve water through the Catch the Rain project, and how technologies can be used for water conservation at grassroots level at post-COVID-19?
Sir, I can answer this, no problem. See, sir, to answer to this question and the prior attendee, what I would suggest, it's my thought which I can share, that all these programs, the missions which have come across, they have come with a very long-term vision and with a change in strategies. So what was earlier happening or what happens at small scale treatment or conservation, here we are looking at the pollution abatement of rivers. And this is where the point source pollution abatement program where we are contributing. There are large people who can contribute in a number of ways. And this is just one way I can contribute as a scientist. So likewise, we all can contribute. So to the earlier speaker, I would say this is a point source strategy, point source pollution abatement strategy where we can help in achieving the treatment at the source so that the treated water can be discharged into drains, or with not discharging if we could possibly make it the quality for reuse application within the system. So therefore, such interventions have their own importance. And then coming to the question of the present attendee. So sir, as you said, water conservation, again, it is very valuable where we are thinking of treatment at large scale. Water conservation at small scale, locality, lakes, ponds, rejuvenation have their own importance. And to come to the question, we can further enhance, we can look at the water quality, which is we are getting as rainwater harvesting you are talking about. So we can look at the water quality and then think of either using it for discharge, for the aquifer recharge, or for possible non-potable applications. So everywhere there is a role, small or big, every technology or every mission, every endeavor has its own role to play at different levels. Thank you.
Now I request Dr. Deen Dayalan M. You may please ask your query, sir.
Yes, madam. Good afternoon. I am Dr. Deen Dayalan, advisor, Central Public Health and Environmental Engineering Organization, Ministry of Housing and Urban. Actually, my organization is promoting new technologies and guide states and cities to promote latest technologies. In fact, in 2013, we brought out manual and sewage and sewage treatment systems, which was circulated to all the states. Recently also, we have been working on the technologies. We have issued advisory on various technologies. Now, I would like to know one thing from Dr. Noorpur. We would like to know exactly what is the capital cost per MLT in terms of capital or O&M, because our experience is the capital cost of biological treatment is lower than the RO-based plant. They were talking about RO, nano-filtration, ultra-filtration, all those things. Definitely cost will be very high. Whether cities will be able to afford that cost, and if you see the cost of water in cities, it is about 5 rupees per kiloliter, generally small towns. For bigger towns like Chennai, Bangalore, the cost of drinking water is about 20 to 25 rupees. But if you go for my experience, we approved one scheme for Chennai desalination plant. The cost per kiloliter was 50 rupees per kiloliter. I will not know exactly what is the cost per KL of water, which is going to be treated through your technology. And also I would like to know all these things so that we will examine all the things. We would like to communicate this technology to all the states and cities for adoption, because government of India is going to come up with the 2 programs, Jal Jeevan Mission Urban and Swachh Bharat Mission 2, which is the emphasis on to provide sewerage and sewage treatment system and also recycling and reuse of wastewater. If this is going to be proven, I think we will communicate this technology to all the states. And we have constituted an expert committee under my chairmanship. I request you to make one more presentation to understand all the efficiency of the technology and communicate to the states. Thank you.
Yes, thank you so much, sir. And we really look forward to the initiatives which you have suggested very well. And regarding the cost, sir, what the overall idea, whatever I presented and I have said many times, that these are the projections, these are the projected costs. What we have come up with a model is that we can discuss, of course, in detail. And secondly, we have to have one pilot installation on site to get the actual techno-economic feasibility, and then only we can commit about a specific cost. So therefore, to go ahead, we can move at for a pilot demonstration first, and then we can go for further technology implementation and transfer and those kinds of things. And regarding the cost, yes, regarding the cost, what currently we are having, we can also share with you the policy brief and the work which we have done. For industrial, if we say with ZLD, the cost, TEDx can bring the cost with current ZLD to 200 to 240, and individually just TEDx alone with our current work 70 to 90 rupees, 70 to 90 rupees per KL for industrial without ZLD. And with regard to sewage, currently we are working on the cost, because as I said, sewage and all these are very newer initiatives which we have done. So we need a chance or the first break for the large scale pilot to get the real techno-economic feasibility. Thank you.
Thank you, Dr. Deen. See, this is actually the idea of this Water Tech Talk. We want to showcase this technologies to various ministries also. They can use it. So I'm happy that you participated and you have received it. In fact, in one of our earlier presentation where Dr. Indra Shekhar Sen had taken up on water quality, he had come out with a tube sort of thing where the water is taken in, stirred, and the quality, the parameters we measured are stored in a resin, and the volume of the material transported for the testing of quality probably reduced by 1/100. So this is the CWC people who are watching the program was really surprised. Instead of 600 liters, they had to carry only 2 liters. 2 kilos, 600 kilos and 2 kilos, that was the saving. So the idea is that we have this type of young scientists who have done a lot of work in India for improving the technology, and our job is actually through this platform trying to link up all of you so that you go ahead. So National Water Mission, if we help in getting you people together to talk, to interact, and then make in India campaign, and along with that through the quality of water and the quantity of water available, we'll be very happy. Thanks a lot, please. Thanks a lot, Dr. Deen Dayal. And next question, go ahead.
So Mr. Deshpande, Amit Deshpande is asking, as I understand, this is photo-activated nano catalyst. If yes, then how does this work in highly turbid industrial effluents?
Yes, sir, you are absolutely right. But therefore, from the process flow diagram, you would have got some idea that primary treatment has its own importance. And the science remains the same. So first of all, the primary treatment will involve reduction in TSS, total suspended solids. And then once the matrix is clear, then only it will come for the secondary stage, secondary treatment involving photocatalytic action. Thank you.
There is a question, not question, in fact, it's a query that what is the sources of these graphs, cost, area, OPEX, etc. Please mention the source.
Yes, as I mentioned, that this report, CSE came up with a very good report on decentralized wastewater treatment systems for sewage. There is a report, and we compared in the same chart. We put across our values in all these all this data, and then we made these plots.
Mr. Chaturvedi is asking, will this STP technology shall be advisable for commercial buildings?
Yes, definitely for commercial spaces. This is again an innovation, and it could be a game changer, because in commercial spaces, the problem what we face is that a huge mall or a huge shopping complex is there where basement parking is utilized for water treatment, first thing. And as we know, in present day, parking is a commercial thing. So more parking if we involve for water treatment, lesser revenues we have. So one thing is that any commercial entity will be happy to have such a technology where bioremediation could be bypassed. It will reduce the footprint, and we can directly use the TEDx for sewage treatment because the capacities will also be less in commercial spaces. So it will have win-win situation for commercial spaces.
I request Mr. Jatin Mehta, you may please ask your query.
Yeah, hello. Yeah, doctor, once again, one query. You had stated that this catalyst needs regeneration. I mean, what is it? Is it very elaborative, like activated carbon, or is it something that can be done in-house, sort of?
Sir, in-house, directly in-house, because we have seen in the process flow anywhere we have not used ever any activated carbon or any resin or carbon filter in our entire process. So the nanomaterial regeneration does not require any activated carbon because activated carbon has a different purpose for water treatment and all. For regeneration of nanomaterials, we are doing at our source, at our own facility. So it could be done very easily. Thank you.
Thank you so much. And though I can still see a couple of questions and couple of queries and comments coming in, but due to paucity of time, we won't be able to take more queries and questions at this point. However, at the National Water Mission website, all these questions which have been asked, they'll be answered there also and uploaded in the form of FAQ there on their website. So maybe you can still write to us and write to National Water Mission for any query if you have pertaining to this particular talk. And with this, we'll officially close the Q&A and over to Ashok ji.
It was a very, very wonderful experience listening to technology, and I hope that the advantages which you have enumerated and very, very clearly made out is noticed by the people who are participating in the seminar, and they will make use of it because your footprint is very low, your quality of the water output is very, very, very high, and I don't know how much that micro nanoparticles cost. Is it a very proprietary technology, or are we on to one company for getting that part? I don't know, but otherwise the technology seems to be absolutely great, and hope that the policymakers will take notice of it. So thanks once again, Nupurji, and I request our Singh to post a formal vote of thanks. Thank you. I request everyone can join us for the water talk on next Friday, similar time, 3 to 5. We will have the water talk also. Probably it will be one very major activist coming up in that. I'm not telling the name because you are getting confirmation on that. Please join us for the next water talk on the next Friday, and of course the next water tech talk will be the next. That's the second Friday of the next month. Thank you.
Thank you very much, sir, for providing me the platform to give the vote of thanks. We are highly thankful to MD sir. When MD sir conceived the idea of Water Tech Talk 7 months ago, we were thinking that the talks will be highly technical and how the interaction with the general public will take place. But as the time passes with every month, the popularity of Water Tech Talk is increasing like anything. So thank you, MD sir, for conceiving such a wonderful idea, for providing a platform for the people of this country to know about the general latest technology used in different sectors of the water. As today's Water Tech Talk is concerned, we are highly thankful to Ms. Nupur Bahadur for giving a talk on this advanced oxidation technology through nanomaterial, which is the presentation was highly technical, elaborative, and useful. She has explained the TADES technology through AOP, advanced oxidation process, and UV nanotechnology through photocatheterization. While explaining the process, after explaining the process, she has shown the case studies also. Case studies she has very elaboratively distributed into industrial waste, and then industrial waste means chemical industries and canneries and etc. And then she came to the difficult water waste, and of course the municipal waste and the wetland waste. These technologies are highly useful, and of course when she compared the cost effectiveness of this technology with other available technologies, this technology was quite cost effective also. And I was surprised that in pharmaceutical and this chemical industry, the BOD and COD is reducing up to 96-93%, which is highly remarkable. So this presentation was extremely elaborative and illustrative. I'm thankful for giving this presentation, and the Q&A section was also excellent and very well conceived questions were put forward by the illustrious participants. I thank all participants also for participating in the 7th Water Tech Talk. Thank you very much. And last but not the least, I'll thank all the officials of NWM who are engaged in organizing this Water Tech Talk along with the Water Digest. Water Digest is highly appreciable. Thank you very much. Back to Anupama, madam.
Thank you, Shri Tej Singh ji. And with this, we finally come to the end of today's Tech Talk, which was very okay. Before I close, I think Dr. Nupur is wanting to say something.
So finally, I would also like to thank for this opportunity and the platform. It is really very valuable. And today I would say that the journey which I began in 2014 with the inspiration of the Namami Gange program. And in these 6 years, journey has been slow but steady, I would say. And another inspiration given regularly, this second, I would say the turning point, this National Water Mission has given this platform. So it is very valuable for me. I really value this opportunity because you get a chance to speak almost every week or month at different conferences and all. But this is so much different and valuable. So I really look forward to moving ahead from here. Thank you so much, Ashok sir. Thank you, Anupama ji, for giving me a chance. Thanks a lot. Bye-bye.
So now we are officially closing it, and we look forward, like Ashok ji mentioned, we look forward to having all of you for the Water Talk, which is next Friday. So please join us, and the links will be shared. We are also live through various Facebook social media platform of Water Digest as well as other ministries platform, including National Water Mission specifically. So please join us for the Water Talk, and I look forward to having your presence in all our events. Thank you so much, and stay safe. Bye-bye.